松田さん聞こえます。
Hello, can you hear me?
Yes.
Okay, thank
Yes.
you. This is a tutorial number 2, Cefore tutorials for CCNx-based cloud native function tutorials. So some information of the URL information in the Slack or the mail email was wrong in the several minutes ago. So please check the latest URLs in the Slack or email. Please, this is a CCNx tutorial, not an NDN tutorials. Okay, so I'll show my screen. Please wait. Can you see the slide? Okay. Can you see slide? Okay. So okay. So hello everyone. I'm Yusak Hamis from NICT Japan. Thank you for coming our tutorials. The first, I'd like to appreciate a lot of efforts of the organizing committees of the ACM in 2022, which is held in Osaka in a hybrid style, and the super big typhoon is approaching. But okay, so I'm glad to be here for presenting and introducing our research activities. CCNx-based cloud native functions, networkings, and its applications. Oops. Sharing stopped. Okay. Can you see my slide? Okay. All right. Just a moment. Just a moment, please. Share this number 2. All right.
さっきのあれやね、USB 持ってきた方がよかったです。USB 持ってきた。
Sure. Okay, can you see? Okay, thank you. I'm sorry for that. Our tutorial is consists of two parts, and the part one is Cefore and its integration with Docker platforms, and part two is a Cefpico. Cefpico is a Python compact package for developing the Cefore applications. So the first part is focusing on the networking aspect, and the second part is for the application aspect of the ICN. After the part one, we have some short break, and we do the part two, and finally we have some time for the Q&A. Okay, I will explain the first one, Cefore, and its integration with Docker platforms. We firstly briefly explained my main motivation and research background, and then we introduced the Cefore, which is a software platform enabling CCNx-based communications. Cefore's name is a CCN-based extensive packet forwarding engine. And next, we explain the Docker platforms and explore the Cefore integration with the Docker through some sample scenarios. Also, we introduces some methods for quickly and scalably constructing the CCNx-based networks. And finally, I'll conclude the part one presentation. This slide might be unnecessary for the most people in here, but I know, but I would like to explain so some beginners for listening these tutorials, especially for the students attending in this conference. So in ICN, Information Centric Networking, a user is called consumer, and which is a request of the contents, and which send the interest packet, which interest is a request packet of the content, and which has a name, for example, the video point MP4, and the interest packet to the server based on the FIB, forwarding information base, which is a routing table, and the data is replied to the consumer, and the routers has a cache, and another consumer is has same the request same content. The data is replied from this cache, and also when the simultaneously another consumer request same content, the interest is aggregated at the router, and the merge case has been occurred, and the data is replied to the both consumer. So there's two main important features in network caching, such as content store and merge case support communications. Merge case is aggregated by the interest. So we have some main features, and we can reduce the traffic and reduce the latency by using these characteristics. So, and dozen years has been passed since the concept of the ICN has been originally advocated. But the original ICN concept is changing the network from the host-centric to the content-centric, as I said previously. And currently, the ICN has been forked to the several concrete network architectures, such as a CCNx and Content-Centric Networking, or NDN, Named Data Networking. Actually, we at ICT developing the Cefore, which is an open source software program enabling the ICN communications. And Cefore is compliant with the CCNx 1.0 packet format, and developed and maintained by the NICT. So far, some research regarding the studies on the routing and the forwarding and the caching and the security and so on that have been widely investigated by the various research communities of the ICN. But one missing piece might be a deployment solution of the developed ICN modules into the existing internet infrastructures. So in these tutorials, we set 3 goals as the pros. So first, we introduced the Cefore, which is an open source software platform enabling the ICN communications using a CCNx messages. We especially highlight the Cefore features for networking and application viewpoints. Second, we focus on the networking aspect and explore the Cefore Docker integration in order to simply and quickly construct ICN networks. We introduce emerging microservice technologies, that is Docker. And third, we also introduce a Python wrapper program named Cefore that helps developing the ICN applications running with Cefore, which this is the application aspect, and the second speaker talk about it. Okay, so let's move to the main contents. Cefore CCNx-based extensive packet forwarding engine. As I said previously, the Cefore is a software platform for CCNx-based communications. The Cefore is compliant with the CCNx 1.0, and which is defined in the RFC 8569 and 8609, and which is standardized by the IRT for ICN, as you know. So Cefore is originally designed in 2016, maybe, so almost 6 years have passed, and Cefore can handle the CCN 1.0 packet, the interest on the content object for the forwarding and the caching. And Cefore is developed and maintained by the NACT, and its source code opened in the following web page and GitHub. Please check the URLs. So in developing the Cefore, we set the 3 design policies. The first one is lightweight. The software should be compact, and the platform should be usable for the resource-constrained devices such as sensor nodes. And the second one is usability. The platform should be easily configured, set up, reloaded, and connected to the experimental environments. Ideally, its emulation or simulation should be easily conducted and tested using real network equipment. The third one is extensibility. The platform should be easily extensible to accommodate the novel functions to satisfy the future network needs. So in order to realize these design policies, we developed the Cefore as a pluggable architectures. As you can see, we can configure the Cefore depending on the situations and the network requirements. Cefore consists of the 2 functions. The CFnet D, which is a packet forwarding engine, and the CS Manager D, which is a caching daemon. And yeah, we describe the details of the CFnet D and the CS Manager later. And for example, if you require a high performance of network performance, you should prepare the high-end machines such as routers and some servers. Then you can enable the various functions by starting a CFnet D and CS Manager D as a full stack ICN node. When you want the middle performance, you should prepare the normal machines such as the PC, and you just enable the core packet forwarding daemon with some extensible plugin such as forwarding strategy and transport plugin. And if you require the minimum implementations with resource-constrained devices such as Raspberry Pi, so you can enable the 783 with minimum functions, providing the basic ICN operations. So researchers can install necessary ICN functions depending on the requirements while considering the massive resource constraints. So this is Cefore's programmable architectures. And I will explain the core components of SafeNet-D, components of Cefore, that is SafeNet-D and CS Manager D. SafeNet-D handles the interest and the contents of packet as the core packet forwarding daemon of the Cefore, and which is a minimum set of provides a minimum set of the ICN functions, that I mean the fib and the pit, to achieve the lightweight implementations. The other compute-intensive functions such as in-network caching and in-network computing are implemented using the plugins or external daemons for providing extensibility and usability. And optionally, SafeNet-D provides a lightweight local caching function. Yeah, this is some option. And CS Manager D is a external cache daemon interacting with SafeNet-D, behaving as a CS, as you know. So, and the CS Manager D connects to the SafeNet-D via the local socket or the TCP connections. So, in order to configure the SafeNet-D or CS Manager D, we prepared some configuration file, and we can SafeNet-D and conf and CS Manager D conf, and we can tune up the parameters dominant for network performance, such as fib size and the bit size, and CS cache capacity, and so on. I'll explain this point later. And yeah, Cefore has a plugin extension function. So in SafeNet-D, there are the two famous plugin we prepared, forwarding strategy plugin and the transport plugin. And the forwarding, Now for forwarding strategy plugin, so there's three choices. You can choose the default strategy or the shortest path minimum cost routing strategy, and the flattening strategy. Flattening means multi-home strategy. And in the transport plugin, it has just a sample plugin for some interest transmissions for the efficient transport. And you can create a new plugins in the future by adding some XX plugin. So researchers can develop the new mechanism without modifying the codes of the core daemons, that is a SafeNet-D, and by using plugin extension, this plugin extension. Okay, so and the researchers can freely modify it and create another forwarding strategy or transport plugin as you want. As is the case with the SafeNet-D, CS Manager D has the cache plugin. You can choose some cache eviction algorithms from the FIFO, LRU, and the LFU. And you can also create some new plugins by adding to the CS Manager D. Okay, so this is a plugins explanation, and Cefore package include useful utilities such as a self-put file and a self-get file for uploading and downloading data files. A self-get file is a consumer-like application, and it is a sample program for downloading named content with simple interest pipelining. The self-get file uses regular interest. Regular interest is normal interest for data retrievers, and Ceph file is a producer-like application, and which is a sample program for uploading a named content to the CS manager D running on the local host. And yeah, content object packets are delivered from the CS to the consumer running the Ceph file. This is one utilities, and also we provide utilities for sending the receiving stream data. That is the Ceph stream and the Ceph stream. And the Ceph stream is a consumer-like application and a sample program for receiving the streaming data, such as a real-time video streaming. And Ceph stream uses a symbolic interest. Symbolic interest is proposed in the following paper, and this is a special interest for efficient transfer. Okay, efficient transfer of the streaming content. And Ceph stream is a producer-like applications and sample programs for sending the streaming data to the one nodes. So, and you can control the sending rate of the data stream with the -R option. Okay, so this is the tools for the streaming content, for transferring stream content, and yeah, CCN info. Cefore provides a CCN info, which is a network operation and management tool, and the specification of the CCN info is defined in the RTF ICN RZ, and by using the CCN info, you can discover the detailed information of the CCNx-based network, such as the routing path information and the RTT between the content forwarder and the consumer. I mean, the content forwarder is some cache node or some producer of the content. And the states of the in-network cached content, such as lifetime or expiry of the cached content, you can check, you can discover some information from the network. Yeah, and this is a list of the Cefore components and some utilities, Ceph-get file and Ceph-put file, and the other command line tools here. I'm not mentioned, but you can check the details from the Cefore web page. Please read me. And yeah, just one point is there we provided some Wireshark plugins, a Lua script for the packet tracing. So yeah, just is information. So okay, so Cefore, in summary, the Cefore provides all-in-one package for CCNx-based communications. You can use Ceph-get file or Ceph-get stream as a consumer applications and publish file system contents by using the Ceph-put file or Ceph-put stream producer applications. In the router node, I mean the CCNx forwarder, Ceph-net is prepared for the packet forwarding and which is configurable by using some plugins such as forwarding strategy and the transport plugin, and yeah, some other plugins. Well, and also CS Manager D is prepared for providing the caching services, and cache plugins and eviction algorithms are also configurable to the according to the situations. So yeah, this is our package for CCNx-based communications. And yeah, for related software programs, Cefpico, we provide Cefpico. Cefpico is a Cefore Python compact package. And Cefpico is a Python-based wrapper program that helps developing CCNx applications running with Cefore and enables the easy coding for the Python programmers. compared to the original C language. For example, as you can see, for sending interest packet in the C language, you need to write 33 lines from the left here. As shown in the left here, you need to write 33 lines. But in Cefore, just import a Cefore library and create a handler and just send a interest packet with specifying this name and some arguments. So you can reduce some coding cost by using this Cefore. And please note that the second speaker will deliver the presentation about this Cefore in detail. In detail. So yeah, please watch the second part of the presentation. And for specifications, for operating OS, we use Linux, Ubuntu 1.18 or later, and the Mac OS. The packet format is CCNx 1.0 and the based on the TLB format. And the NHCT original function is we add it in the optional hop-up header. And for networking, we choose the TCP or UDP over the IP style communication. I mean the overlay style communications. Okay, so this is the main introduction of the Cefore. So from the now, let me move to the next section, the Cefore Docker integration. So this slide briefly explains what is Docker and the great benefit of the Docker when applying it to the construct ICN networks. As you know, Docker is a famous platform for container-based virtualization technologies for quick and scalable deployment of network services. There are three important benefits. The first one is lightweight. A Docker container is a very lightweight compared with VM, as you can see in the right here, because they have no OS in the Docker. So they can, so we can build many containers in the one physical machine. This enriches the evaluation scenarios of the ICN networks and improves the scalability of the experiments. For the performance, the Docker containers do not have OS, so they can be easily and quickly initiated and terminated. So this facilitates the comfortable test and evaluation of the ICN services. And the third point is scalability. So there is a requirement that multiple ICN nodes providing different functions coexist in a network. So the concept of the microservices that in each service image is built for the purpose of the fits these requirements. So useful options tools such as Docker Compose can be used for the flexibility and quickly setting up the Docker containers. So we use the Docker for the networking. And for preparation, you can follow this. For Ubuntu users, you can follow the official introduction, which is a very kind introduction. And for Mac OS and Windows UOS, I would recommend to use some Docker desktop applications, which is a very simple applications for with GUI-based simple applications. Yeah. And this slide shows the minimum and recommended spec of the host machine running the Docker engine. For CPU, minimally you need 4 cores, and I would recommend 8 cores. But for Mac OS, the Intel chips are recommended, not the Apple Silicon chip M1 or M2, because we never tested in the Apple Silicon chip, so I would recommend Intel chips. For the memory, you need a minimally on 4 GB, and I would recommend 8 GB. But please note that the machine spec should be considered according to the scenarios of the experiments which you want to run with the Docker containers. Okay, so it depends on the scenarios. Okay, and we here is a very simple example scenarios of the Cefore Docker based networking. So, for example, if you like to construct a simple ICN network with 3 nodes consisting of the consumer and the router and the producer, you can define the 2 types of services. For example, minimum services and cache services. The minimum services is used for the end applications and the end host, and the cache service is used for the router and the producer of the content that provides the caching functions. And in these scenarios, the consumer requests a file and the producer responds to the request and they send back the data. And the CCNx router stores or receive the data into the CS, the CS manager D. So this is very simple scenarios. So in order to realize this, we need to prepare the several kinds of Docker files. To build the Docker images of the Cefore, we first prepare the base images, Docker files as follows. This file is for the base function and just define the necessary functions of for providing ICN services as a container node. So in this Docker file, we build base image as use Ubuntu 2.20, and just install some basic libraries for the building Cefore, build essential and leave SSL and the automate. And you just download the Cefore software from the GitHub URL. And this is a base Docker file images. And afterward, the other enhanced ICN services, that is minimum services and the cache services, inherit this base images. So this is a basic component. And for enhancing the service functions as an ICN, and we can optionally define the prepared Docker file, and the minimum function is for the installation and the application preparation. So end hosts do not require any special functions, so the file can be writing as a follows. So in the line 3 or 4, we just configure and then build the Cefore and install the Cefore into the Docker images, and we just set the entry point, that is starting point of the process, and just starting the Cefore daemon Cefnet D. So we can define the service minimum services that provide the minimum ICN functions, application tools. So, and example 3 is for, in order to adding the caching functions, we define the cache services. So in the Docker file, we build from the base images and just enable some caching functions of for Cefore configurations by enabling the cache and enable the CS manager option. and just make the build and yeah, install it. And you need to modify the configuration file for the caching, for providing caching services. So in the CS mode is 2 is which means CS manager. We use the CS manager D for the caching function, and in the cache type memory means yeah, you can choose the cache type of the for caching content. I mean, you can choose memory RAM caching or file system caching. So you can choose it from by selecting the in the CS manager dconf, and you can you can set the entry point. That means starting the Cefore daemons. So I mean the Cefnet D and the CS manager D. So by doing so, we can define the cache services by adding caching functions, cache or CS manager D, to the base image functions. So okay, this is how to write the Docker files of the Cefore images. And yeah, there is another tools for kind construction of the ICN Docker Compose. So we prepared some Docker file server, and then we can utilize a Docker Compose to quickly and simply construct the ICN networks. A Docker Compose is a tool for defining and running multiple container Docker applications. And we can easily configure the service by using a YAML style scripting. And with Docker Compose, we can create and start all the services from the configuration with a single command. So it is very easy to conduct scenario-based experiment emulations, like network simulations such as NF3. Yeah, it's just my opinion. So this is very useful tools for constructing ICN networks. And as you can see in the right here, so there are 3 microservices, producer and the router and the consumer, and you can specify the images. Producer is for the cache, router is set up with cache images, and the consumer is set up with minimum images, and you can specify the name of the container and host name and some setting. You can easily do your setting, and you can create some networks and set the IP addresses of the each container node easily. So I would recommend to use some this Docker Compose for constructing the network. Okay, so now we have introduced some basic of the main software, Cefore and Docker. So from now, we will move to some practice and show some basic operations for demonstrating how to use the Cefore Docker networking. So, okay, this is an introduction how to manually install the Cefore. Actually, we use a Docker installation, so this slide might be unnecessary, but I will show some manual installations. And first one, you need to download some source code from the Cefore website or the GitHub, and you just install the dependencies, libs and automake, and just install the Cefore, unzip the zip file, and configure them, and build and install. Yeah, sometimes you need to conduct as LD config. And binaries are, yeah, to be installed in the user local bin or SBin. So please see more detail in section 2 installation of the README. Yeah, there's a kind introduction of the installation for depending on the your machines. Okay, so yeah, so this is some introduction to how to use Docker. So it's very not general one. So, but I will explain some procedures. So we just yeah, you can build some images by using a Docker build option, and you can check the status of the build images by Docker image command, and you can start the container by specifying the name of the Docker build images and or image ID. And yeah, you can log into the Docker exec by specifying the consume and some shell file. And okay, for stopping the Docker, you just exit from the Docker or use the stop command, and then you can remove some container images by using the following command, and you can purge all the related cache images. But yeah, this command should be run carefully, because this command will remove the old images of the build images. So yeah, you need to take care of it. Yeah, this is a Docker instructions, and from now I will do I will show some examples. All right. Okay, I will show the terminal, and I will show how to stop and safenet D, and just a moment, please. Finish. Okay. I will SSH to the server in the NICT, my office, and yeah, I will show some how to do some. Okay, just a moment, and and yeah, I prepared some bash script for constructing some Docker images. So I just use this script for creating the Docker containers. So yeah, by seeing this, yeah, you can see the Docker container is created, and some container node has been initiated. So in this time, I'm now in the host machine, and you can use Docker exec command, this command, for accessing the Docker image, build Docker images. So exec name is ICN consumer. Muted.
No, Hayami-san, we cannot see your screen.
Okay.
Yes.
Thank you for, yeah. I'll show it again.
Oh, yeah.
I'm sorry.
Works, no?
Sorry.
Yeah, it's
So
okay.
I forgot to, yeah, share my screens. Thank you for your instruction. Oh, okay. I'm now using the terminal, and I try to do some operations of Cefore operations. And yeah, you can use the Docker exec command for accessing the ICN consumer node. I built it before. Yeah, now accessed, and yeah. And yeah, from this, right? So you can stop the Cepnet daemon by using the Cepnet stop command. And you can also start the Cepnet command with the Cepnet start. And you can check the status whether the Cepnet is successfully created by using Ceph status command. And also, okay, I will access to the router node. Router node. And you can stop the CS manager D by using CS manager D stop command, and you can restart the CS manager D by using the this command. And yeah, so Cepnet D, you can check the status of Cepnet D by using Ceph status command. So yeah, you can see the version of the CCNx version and the received number of the received interest and the transmitted interest and received contents object and transferred content object number and the cache mode. Cache mode means EX cache means we use the CS manager D for the caching. And there's a face table and FIB, forwarding information base, and the bit entry. And yeah, by optionally, we can check the build version of the Cefore by using the -p option. The current latest version is 0.9.0b is the latest one, which is opened in the GitHub. And also, yeah, I'll do some sample scenarios. Just a moment. I have access to the producer node and just put some before putting the just in the producer node, so we to the file images, I'll copy it from. I'll put a content to the producer node and the content name BBB, which is a second content. And yeah, the third content, we put the three content, and you can check the CS manager daemon by status command, by using a status command and specifying the name prefix. Sorry. CS manager status. Yeah, you can see the three content is stored in the content store, and whose name is AABBBCCC, and yeah, three content is stored, and also you can specify the name prefix by arguments with arguments, so you can limit the contents which is shown in the CS manager D status command. Yeah, this is how to check the status of the CS manager D. And also we have the FIB management tools for the safe route. And initially I exit from this router node, and you can check the safe status command, and one FIB entry is registered in the current state, and you can add static route by using a safe route add CCNx by selecting name prefix and choose the connection type TCP or UDP. In this time I will use the UDP and specify the neighbor's IP address. And you can see the new FIB entry is static entry is registered in this phase 22. And also you can remove this entry by using the route there. CCNx, oops, sorry. B 1. Yeah, the FIB entry is successfully deleted from the SafeNet D. And there's alternative solutions for preparing the FIB entry. We provide some configuration file in the local SafeNet to the point FIP. Yeah, this is an example FIB entry. By adding this to the file, and you just reboot the them. SafeNet D automatically loads this file when starting its process, so you can see the example FIB entry is registered. Yeah, and also that we are now developing some routing protocol, but today we don't talk about it. So anyway, you can create the FIB and you can create some networks, small networks, by using this FIB management tools. And for tuning up Cefore, there are some primary parameters, SafeNet D conf and the CS manager D conf. And in SafeNet D conf, you can choose the CS mode. So CS mode 0 means no content store is prepared, and CS mode 1 means SafeNet D's local cache is used. And CS mode 2 is use external content store, I mean the CS manager D. And for forwarding strategy, you can choose that from the default and the flattening and the shortest path. And as I said previously, and the CS manager D conf, you can choose the cache capacity. The maximum, I mean, the cache capacity is the maximum number of the cached components object in the CS manager D. And you can choose the cache type from the file system or memory. Yeah, and you can also choose the cache eviction algorithms from the FIFO, LRU, and the AFU. And the other configuration parameters are listed as follows. And for debugging, so you can select a debug level of the 7D from the range 0 to 3. The 3 is the most finest debug information. You can get some informations, and you can specify the port number and the bit size and field size, and yeah, CS mode, as I mentioned previously, and you can specify the CS manager node's IP address. Original address is a local host, but you can specify some other node by using the TCP connections. So yeah, you can choose some IP address, and for port number, yeah, also you can specify it. Yeah, please see the README for detail about the configurations of the SafeNet D and CS manager D. And there's some tips for in experimentally we would recommend to increase the socket buffer size of the kernel parameters in advance when you conduct high-speed data rate experiments. For Ubuntu, you can use these control parameters and increase some receiving and reading and writing buffer for the socket. Okay, so now let me introduce some sample scenarios for Docker-based networking. Okay. So in this scenario, this is a basic scenarios for file transfer. In this scenario, consumer requests a file whose name is CCNx/video.mp4, and it is stored in this CS manager D, and consumer requests the cached content by using self-get file command, and check some statics informations of the consumer, such as throughput and latency or some information, and we check the SafeNet D status and the CS manager D status in the router node. Okay, I will show it from the. Please wait, I'll prepare it. This is a producer node, and consumer router node, and this is for consumer. Tutorials. Yeah, I will just reboot the environment. Okay, so yeah, it's rebooted. So I have access to some node. Select the ICN consumer on the specify the some scripts bash and access to the router node. Access to the producer node. Yeah, and okay, it's fine. So the first producer put the file Cefore put a file video .mp4, which is the name, and specify the file. Yeah, just put it. Yeah, done. And at the consumer node, specify the name. Use a self-get file command. You can specify the name video .mp4, and then you can specify the output file .mp4, for example. So just do the command and then complete it. So you can receive the about 3 megabyte file, video file, and the duration is 300 millisec about. So totally 74 megabps maybe. So yeah. Also you can check the self status. And 2000, yeah, interest is transferred and the data is received, replied back, and yeah, you can see the some status. And for CS manager, not the status. CCNx/0. Yeah, the video file is stored in this router node. Yeah, this is a basic scenario that for transferring some video file. And also, next we'll explain the video streaming scenarios. Next scenario is the video scenarios, and use the self-put stream and self-get stream command. In these scenarios, the producer publishes the stream data, which is the same file, and to the consumer with the self-put stream command. And the consumer sends a symbolic interest packet to receive the data stream with self-get stream command. And the host OS is waiting for the playback with ffplay command, which is a component of the FFmpeg. And yeah, after receiving the video, consumer start to watching the video. So I will show you the GUI based demonstration, but I will show some demonstration video. Oops, sorry. Okay. The first, we start some container images and create a network. And yeah, we access to the some Docker node. Leftmost is a consumer and a router and a producer. And yeah, in the producer node, we prepare to type the self-put stream command. The transfer file is a big bunny file stored in this directory, and specify the rate, sending rate to the each 1 Mbps. And yeah, at the consumer, we use the self-get stream command and specify the same name for the communication, and we can specify the sending interval of the symbolic interest packet. In this example, we use 2 seconds for the interest transmission. And yeah, just receive the data is stored into this file, and this file is shared with the host machine by using a shared directory. And yeah, in the initial state, the router is an initial state, so there's no interest and the content object is transferred in this stats command. Yeah, and we just some setting for this is a playback command I used. So we just wait the ff play command and wait to the download. So and now producer node we put some the video file, and the consumer send send the interest packet, and the video is started. And yeah, you can see the interest is periodically send it, and the video is successfully received by the consumer, and yeah, you can see the and also you can check the status of the router node, and 15 symbolic interest packet is transferred, and in the data, for data, so 2000, more than 2000 data content object packet is replied back to the consumer. So this is a demonstration of the Docker-based Cefore networking for the video streaming. Okay, and oops. Yeah, this is some just the information for your information. So last year in the IIC, which is a Japanese society, and we have some ICN summer workshop 2021. It is free online style, and we did a Cefore Docker hands-on in the we do the multicast video streaming using Cefore Docker platforms, and we did it over the internet. And so, I mean, the producer is located at the Tokyo NICT, and the consumers, it means attendees of the ICN workshop, and they received video streaming from Kanazawa or Hakata, Hiroshima, or Osaka, Nagoya, or something. And yeah, consumer receive the video streaming from their home or schools or companies. And yeah, you can get some code from this workshop in the GitHub, but the materials are in Japanese only, so please take care of it. So yeah, this is some information. So okay, so now I will conclude my part. And first I introduce Cefore CCNx-based extensible packet forwarding engine, and Cefore provides a Oregon package for CCNx-based communications. And we move to the Docker, try to explore the Docker integration with Cefore. And because Docker is a quick and scalable deployment CCNx functions. So, and we introduce some sample scenarios for file transfer and video streaming. And the future work, we pass the possibility of the collaboration with emerging Docker orchestration technologies such as Kubernetes. Yeah, this is my part of the presentation, and there's some reference. Please check them. And thank you. I will conclude my presentation. Thank you for your kind attention. And so, okay, so I'm just I will have some break for the 20 minutes break. Okay, so I have a 20 minutes break.
Harry,
So
is it possible to ask questions? There are some questions in the Slack channel.
yeah, so you can use a Slack and post some questions, and yeah, after the
There are
part
some,
2, yeah,
there are
we
some
will,
questions there already in the Slack about your part.
sorry. Yeah,
So
you can
some
use,
people have posted questions in the Slack already
yeah,
about your
yeah.
part. Do you want to, are you going to hold everything until the very end, or we have
Yeah,
time
everything
now?
is in the end. So question part, please, after listening to the part 2, we move to the Q&A session. Okay, so please come back again at the 9:30. The part 2 will start at 9:30. Thank you for your attention.
Okay, so can you hear me? Okay, it's okay.
Yes.
Okay, so hello, I'm Kazuhisa Matsuzono on NICT Japan. So as a second part of this tutorial session, I'd like to talk about Cefore, which is a Python compact package for developing Cefore applications. Here are contents I'm going to talk about in this tutorial part. First, I'll introduce the Cefore overview and the features. And then I'll explain how to install and use it. Then I'll explain Cefore basics, that is, how to execute ICN communications using Cefore and Cefore, which is explained before, and how to implement simple consumer and producer applications. And finally, let me introduce some sample applications as long as time allows. Okay, so let's get started. First, let me talk about what is Cefore and why it is needed. So as mentioned in the previous part of this tutorial session, Cefore is written by C language. So we usually use C language to make Cefore applications, but C language is a little bit difficult to make applications simply, easily, and fastly. Thus, there are many requests to easily do programming to make some Cefore applications for enabling ICN-based communications, mostly from university students or those who want to try to use ICN-based communications. So that's why Atsushi Ooka developed and provided a Cefore Python package enabling a user-friendly implementation, as developers can call CCNx functions as sending interest and data packets. Here is two sample codes to send an interest packet. So we can see that in the case of using C language only, it's 33 code lines. On the other hand, in the case of using Python Cefore, it's just 4 lines. So Cefore is simple and easier to write than developing C language. So next, let me talk about how to install Cefore. So we can download Cefore source code from this website, which includes Cefore manual. Okay, so regarding how to build and install Cefore. So here, I assume that Cefore has been successfully installed in this situation. Building and installing Cefore is so simple and easy. In the case of Ubuntu Linux, we need to install this package by apt-get and then install Python package by pip. In the case of Mac, in a similar way to Ubuntu, we need to install this package. After install this package, we need to compile using CMake, like this. Okay, so let's so please wait. Okay, this is a Cefore already downloaded Cefore, and we just CMake. Then sudo make install. Okay. Then in order to check if Cefore is installed properly, we can check by run Python 3 and import Cefore. Okay. If no errors, this Cefore installation is okay. Okay, so next I'd like to explain Cefore or basics, how to use it. Okay, here I'd like to explain how to use Cefore or to execute ICN-based communications. First, let me explain four main methods of Cefore using my PC where Cefore and Cefore is already installed. So more specifically, creator handle method, which connects to CeforeNet-D, Cefore forwarding daemon, and send data method, which is used to send a data packet with a specified name and a chunk number and a payload. The third method is send interest, which sends an interest packet with a specified name and the chunk number. The last method is receive method, which is used to receive an interest or data packet. After explaining these four main methods, let's consider how to implement a simple consumer and producer application by using these basic Cefore methods. At a simple producer Python program, we need to use register method for the application to receive an interest with a specified name. Then finally, as long as time allows, I'd like to introduce sample applications using Cefore and Cefore. Okay, first, let me talk about create handle method, which is a very important method because it's used for the application to connect SafeNetly, which is a Cefore core forwarding demo. Let's create a test, this test1.py program to check if it properly works. Okay, here's the terminal on my laptop PC. So first, I need to run CS Manager D. So that means Cefore content store. So let's check /user local Cefore CFNetD this configure file. So in order to use CS Manager D, okay, we set this CS mode to number 2. This one, use external content store, use CS Manager D. Okay. Then let's start CS Manager D. So, okay, then we need to run SafeNetD. Okay, so now SafeNetD is running while we're using CS Manager D. So then, so we can check SafeNetD status by using self-status command. Okay, we can check the this one. Cache mode is exactly set to external cache mode. Then, okay, so let's start, let's run this program. So, okay. Okay. So if no, like this, if no error message, this program properly connects to SafeNetD and then finish the properly. Here's additional information regarding Python syntax. So just in case, let me briefly explain it. Sentence and the blocks are represented by indents instead of semicolon and parentheses as in C language. Wait statement is so useful because as we can see the below table, it enables exception handling to make the code clear and much more readable. So turning now to send data method. So like this test2.py this program, we can specify the name, the content as strings, chunk number, and cache time. So let's check that this test program works well by conducting this procedure 2. Okay, so now CS Manager D and SafeNet D both are already running. So we just okay. So we are. I'm now trying to send interest packet by running this code. Okay, so this self-pico Python program now sent this interest packet, and we can check the this interest packet was properly sent to this definitely by using this command. So this command enabled us to check the CS Manager D status. Sorry, not the interest packet. So this program sent a data packet. So now we can see that yeah, here we can see that the data is stored in this CS Manager demo. So next, I'd like to turn to send interest method, which is so simple. We just need to specify the name and the chunk number, and then call this method. This program send an interest to get the data, which is named CCNx:/test. This one. Okay, let's run this program test3.py. Okay, this program is now just sent the interest packet. Then we can check this interest packet was sent properly to Cefore by using this command. Yes. So we can check the access count. We can see that so because this Python program just sent one interest packet with the name CCNx-test. So this access count was increased by 1. Okay. So next, I'd like to talk about the receive method, which enables to receive an interest or data packet. This typical program test for .py is trying to send an interest and receive the corresponding data. After receiving the data, this program shows the content of received data. So if we want to receive interest packet, we need to use register method, this one, which is now commented out. I'll use this register method later on. And this receive method wait for a packet for about 4 seconds after execution. So if we want to receive it until success, while loop or other syntax is required. When successful, this method returns a CCN packet info object. I'll show the more details about the CCN packet info later on. Okay, so let's run test test4.py. To see what kind of message is shown. Okay. Yes. So when data is successful, when data reception is successful, the message is shown like this, which includes the data name, chunk number, and the content of the payload. Here is a list of CCN packet info properties. According to the received packet type, interest or data, we can get 3 properties. We can get these properties. It succeeded, it failed, is interest is data, the name and the name length, chunk number, and the information about the payload, and some other additional information. And the chunk number can be seen only when the data publisher specifies it. Okay, so next, let me talk about how to implement simple consumer and the producer applications. Here, let's consider a simple consumer self-pico program, which is trying to receive a content of which the name CCNx CCNx:/test, and the chunk number is 0. Until the data packet reception success, it's needed to repeat receive function. So let's think about how to complete this simple consumer program. So we need to make up these 3 parts. Okay, let's see a sample answer code, simple consumer application. So in this send interest method, we need to specify the interest name and the chunk number. So, and in this conditional statement, we check if the received packet is data, and the data name is CCNx:/test, and the chunk number is 0. If so, it's going to show the received content and execute break. So let's run this scenario using this program to check how it works. So we can check the now okay. The CS manager already stores this content, so I omitted this procedure. So that is I don't use save to file program. Okay. Then I'm going to run this simple consumer program. Okay. So this program is to send an interest packet with the name of CCNx:/test, and then successfully received the corresponding data from the CS manager demo. So next, I'd like to turn to a simple producer self-pico program, which need to register method to receive interest packets. This register method can be used to register the specified name prefix so that this program can receive interest packets with a name that arrives at this SafeNet. So let's think about how to complete this simple producer self-pico program, which sends data of hello. It's sent out after receiving interest named CCNx:/test. Okay, so let's see the this is a sample answer code for simple produce application. It's so simple, as we can see. We just use a register method to receive the interest, and we set this condition statement, this line. And use send data method to return the corresponding data. So let's see how this simple producer works together with a simple consumer program. So in this scenario, this simple producer responds to the received interest and return the corresponding data. So we don't need to, in this scenario, we don't need to the content store CS manager D. So let's disable it by editing this config file. Yes, we need to change this CS mode from to 0. So 0 means definitely doesn't use content store. So then, so currently, definitely and CS Manager D are already running. So I'm going to stop. Okay, let's run the definitely. So okay. Then I'm going to check the cache mode. Okay, so we can check the so current cache mode is none. So that means this definitely doesn't use doesn't use cache. Then okay, so let's try to the this simple producer programming and consumer program. Good. So first, I'm going to run the simple producer program. Okay, so it's now this producer program is running, and then I'm going to run the simple consumer program. Okay. So as we can see that this program, producer program, receives interest, and then respond to the received interest by sending the corresponding data. Then this consumer program will receive the specified data, and finally this program shows the content of the received data. Okay, so this is a list of the summarized Cefore APIs. So we can check the details about the arguments of each method. So we don't need begin and APIs when using with the statement. So by using the deregister method, we can unregister the name prefix registered by the register method. So next, let me talk about the sample applications using Cefore and Cefore. So Cefore provides already two sample applications, Cefore App Consumer and Cefore App Producer application. These source codes are located in the Cefore or /Cefore App directory. So these codes already included the downloaded Cefore source. The feature of this sample application is that Cefore App Consumer sends out an interest and receives data, while Cefore App Producer listens for an interest and sends data. Three types of input output can be selected: inline, standard input, output, and file. Cefore App Consumer implements pipeline processing and can communicate with Cefore App Producer at high speed. So we can refer to README in this URL for more details. So next, I'd like to turn to another sample application for push communication. So as you know, ICN-based communication is pull-based communication where a consumer sends an interest with the name of content retrieved and then obtains the corresponding data from the network cache. For instance, in IoT system, a node sends an interest to get the current temperature. However, in IoT system, push communication is often required to where a sender node wants to push some data into a server, like this figure below. So we have two simple possible ways to enable such push communication. First, the idea is that the sender node puts information on the interest and send it to the server. So this method is so simple, but deviates from the ICN principle that one interest receives at the most one data packet, and there are some other difficulties. As another method, we can say that pull communication is considered a network function that pulls data from a cache in a network. So it is to define a network function that pushes some data to a network and call the function name for push communication. So from here, let's consider such a network function for push communication by using Cefore. This figure shows a system based on the network function where a sensor node push consumer sends an interest that calls a network function for push communication. And then a server, push server, sends some specified interest for this sensor node to push data. And finally, the sender sends out data, including the message of 30 degrees Celsius to the server. At first, we need to define a naming scheme. Here's a simple naming example. In this case, the first name segment means a function name, and the second name segment means a total number of chunks of data to push. And the third segment name means the name of the data to push. As an example of interest name to call a push function, we have like this. So this is an example of a simple push server program. At the first procedure, this server specifies the interest name using the function name to accept the push function request. So it uses register function by using the interest name prefix, and then call receive method to wait for such push requests. At the second procedure, after receiving a push request, it issues an interest with the name of data to push, which is specified by the push consumer. As a final procedure, this server tries to receive pushed data until the number of received chunks becomes a number specified in the function call interest by the push consumer. So this is an example of simple push consumer program. So at first, this consumer needs to issue an interest to call the push function based on the predefined naming rule. The consumer sends such an interest. Then, in order to receive some interest from the server to push the data, this consumer uses a register method by specifying the interest name prefix and run receive method. At the third procedure, after receiving such interest from the server, the consumer pushed the data by responding to the received interest. So next, just in case, let me explain the preparation before executing these sample programs. So there are some configurations we need to do. At the sensor node, we need to execute the following command to set field, forwarding information base. At the server node, we need to execute the following command to set field. And also, in order to cache received data, make sure the cache mode is local cache by using safe status command, as I did just before. So yes, so we can easily check if the settings are properly done by seeing the messages shown by safe status command, like this. So here is a procedure to run these sample application programs. So let me exactly run this procedure. Okay, here we need to use local cache mode. So I'm now going to edit the SafeNetD configure file. So yes, I need to change this CS mode to 1. Okay, so let's run the SafeNetD. Okay, first I'm going to run the push server program. Yes, so this program is now waiting for the push request. Okay, then I'm now going to run the simple push consumer program. Okay, so this project program receives a push request from this consumer, and then this producer sends a 5 interest to this consumer, and then after receiving this 5 interest, this consumer push the corresponding data to this server. Then this producer program shows the pushed content like this. Okay. So if we restart this scenario again, we need to erase the data cache already. So we need to stop and restart SafeNetD at the server node. So from here, this slide introduce and explain the sample application using SenseHut sensor node. So if you are interested in the sample application, please refer to these slides. So we provided measure methods for getting sensor information, which is provided by sensor node. And we provided sample application using SenseHut. And we provided the sample simple source code. Okay, thank you so much. So, okay.
Can you hear me? Okay, so now let's move to the Q&A. So maybe some question is already answered by some Asayara-san or some, yeah. So we'll pick up some questions and I will answer them. And some other questions is will be replied in the Slack. Okay. So the first questions are regarding the platform requirements from the Ken, and the question is the question regarding platform requirements. I don't know the Docker. It is for CPUs requirement on the hardware. So the answer is this platform requirement is for the host machine running the Docker engine. So maybe you need a 4-core for the host OS in the minimum for conducting the Docker containers. But I would recommend to use 8 cores or more for getting the stable results and performance. This is our question answer. And the second question is regarding the shortest path forwarding strategy, and from the so I missed the question. Shortest path forwarding strategy from the Kanai sensei, and yeah, the question is what kind of metrics we can use, number of hops or RTT. The answer is routing cost is used for the shortest path routing, and I mean the hop count is used, not RTT or some other metrics. So the routing cost is shortest path means minimum cost routing cost strategy. So and the next question is for the symbolic interest, please download the paper, and I posted it in URL, and please see the conference paper, and the specification is described in the URL. So, and also, is there any support for signature validation or on packets or key management? So, regarding the second question, in the content of the packets, signature validations are supported in the current version Cefore. So please keep in mind. And next question is from the Mr. Sampson. And how do you determine the consumer machine status and the resource breeze? Presume there is a agent on the consumer machine. So in Docker-based networking, so you don't have to distinguish each service. I mean, that is Docker or router producer or something. So you just need to care about the host machine specs. So no agent in the consumer node, I think. This is our answer. If you have any more questions, please post it in the Slack. And yeah, okay, let's move to next questions. From the monitoring questions tools from Kanai-san, are there any questions tools for the ICN router status? It is very handy if we can collect the log info such as CCNx CS status and FYB without hitting command manually. So yeah, actually in the current Cefore, we have no tools for such requirements, but you can use debug mode for logging this information in the CS and FIB. After logging them into some file, and please pick up the necessary information on your need. But yeah, please note that this method is only available for the low-speed transmission because it is, as you know, debug mode. So yeah, please just keep in mind. So okay, so this is the answer. And the last question is from the Ueda-san. Is there any difference between Cefore.net code or Cefore codes and in the web and the GitHub? So as I answered in the reply, yeah, GitHub code is the latest. So please download from the GitHub about the Cefore. Yeah, I will replace the web page source code later. So please check, download it from the GitHub. GitHub has a latest source code and the latest English manual. So please download it from the GitHub about the Cefore source code. So yeah, now is the time for concluding, finishing this tutorials. Thank you for your kind attentions. And if you have any additional questions, please post it in the Slack. We are all very welcome to answer them. So thank you for your kind attention.